Hey, Samuel.
Hey, Priya.
So, welcome to the first interview. In this interview, you're gonna have to answer two questions, two coding questions. And at the end of the interview, you have 5 to 10 minutes to ask me anything you'd like. Um,
Sounds
do
good.
you have any questions before we start?
Nope, I don't.
Okay, perfect. So the first question is called generate parentheses. So basically, given n pairs of parentheses, you want to write a function to generate all the combinations possible of well-formed parentheses. So here's an explanation, and then I will show you a couple examples. So some example inputs that you can also use during your solution. But basically, if you input 3, you output these pairs, and as you can see here, there's 3 pairs of parentheses here in different combinations. So when n is equal to 3, you just want to output these 3 combinations. The order does not matter though. I'll put in n equals 1, so you have another example to work off of, and that's the only possible combination. So yeah, that is the question. Let me know if you have any questions, and I'm here to help you out as you work through it.
Okay, sounds good. I think this question is very clear. Like, I don't think I need to ask any clarifying questions, but just to reiterate, you're basically given some n. You want to have n opens and n closes, and you want to return a list of all the valid combinations of valid parentheses. Is that right?
Correct. Yeah.
Okay, cool. Then I think I'll maybe I'll first kind of walk through like my thought process of what a valid parenthesis is. And I think a valid parenthesis can be described as two things. It's a valid parenthesis if every prefix of the string has more opens than closes, right? So you can never have, what this basically says is that you can never have a parenthesis string where it's like this, right? Because the first prefix, which is the first character, has more closes than opens. So this is not valid, right?
Yeah.
So every prefix of the string, and there's n of them for an n length string, must have more opens than closes. And then the second constraint of a valid parenthesis is that the total opens must equals the total closes. Okay.
Yep.
So given this definition of what a valid parenthesis is, we can keep these two definitions in mind and then just start generating. And make sure that if any of these two constraints are not held, then just either break or just close out of that function if we do have some function. Okay,
correct.
So I think a natural, we can do this both recursively and iteratively. I'm going to do this recursively. And I'll first start by instantiating list. Actually, before I code, let me walk through the algorithm itself. So what we're going to do is say, hey, we want a target string of length 2 times n, right? Because we want n opens and n closes. And then at every step, right? So basically we have 2 n slots. Let's say we have 2 n slots of characters we need to fill. At each slot, it can either be an open, right, or a close. Right? So at every slot, we have 2 options. And so if we have some recursive function that walks through each index of the slot and just fills in either open or close, we're going to look through every single combination. Now, we have to keep in mind, though, that we want to keep those 2 constraints up top in line 16 and line 18 in mind, right? So this means that we need to keep track of, first, how many opens there are and how many closes there are, right? Because if we have these 2 information, we'll always be able to keep those valid parentheses constraints in mind. And then for each index, we'll fill it in, open or close. And then we'll check, hey, is this a valid parenthesis so far? If not, we'll return out of that immediately. And then the base case, right, since it's a recursive function, we're going to get to some final state, is when we have 2 times n minus characters we filled, and then our constraints are fulfilled correctly, and then we'll add it to our array list of valid parentheses. Does that make sense?
Yep, that sounds good to me.
Okay. So we can do it the following way. We'll say that we have some function that just recurses. We'll call this function recurse, and it'll keep track of open, the number of opens, and the number of closes, and the string current. I'm going to use a string here. Instead of a string builder, we can optimize it using a string builder, but I'll first use a string in case you don't know what exactly a string builder is. But basically, this function will do all our work, and then we're just going to recurse. And we'll say 0, 0, and then empty string. And then we'll assume this function works, and we'll implement that later, and we'll return res. Okay. And this res will be a global variable that we added to later. Just okay. So let's first start with our base case. Our base case, as we said, is if open, right, equals some n, and I'll actually instantiate this n as a global variable so that we don't have to pass it in. We'll say, hey, if this open is equal to n and our close is equal to n, then we will say, we'll add this to our result, global result, and then we'll just close out of this loop. Now here's our 2 cases here, right? This is not our base case. So this was currently our base case. And we have 2 cases here. We say if open is greater than closes, right? So that we must always have a valid case, and we can only have it when, so this is add a close. So hey, we'll curse open closes +1, and then we'll add a close. And we could always add an open, right? If open is less than n, then we can still recurse. And so this should work. Closes, open, greater closes, and n is less than n. We'll just make sure these constraints are held. Okay. And yeah, I think I'll be extra careful and say, hey, if any of these are true, return, because we never want either of them to be greater than n.
Yep.
And yeah, and
do you want to try running it with
sure,
with n equals 1 or n equals 2?
Yep.
And see what it prints out.
Not find symbol. We didn't import it. Is that what it is? Yes. Import java.util. Let's run it again. Let's see. What compiler did we just so cannot find simple. Oh, okay. Okay. Let me make a static function. Static function.
Yeah.
Okay, actually, we can't make it a static function. Let me just let me do it the proper way. Okay, so and then solution dot. Casting. What happened here?
So it seems like it's
Didn't print
going-
anything. Is that what it is?
it's going on forever.
Oh, okay. Okay, then let's try to debug this by printing cur in the recursive function. Okay, so print and
Okay.
open,
Prints out the open.
and then oh, okay, okay. Hold on. There you go. I accidentally had it less than instead of less than or equal to. Let me run that again. Okay.
Okay. There's more progress.
There's more progress. 42. Null pointer exception. Let me just delete that print statement. Run it again.
Okay. So it's failing at line 40. That's the add cur.
Okay, we didn't instantiate res. So yeah, okay. Let me move this.
Yeah.
So on line 33, I changed it before the recurse function. Since it is a global variable. Okay.
There you go.
All right. And let's try for n equals 3.
So that looks good to me. Yeah, let's try n equals 3. Perfect. Let's see, let's count these. Yeah, this looks good.
Good to me.
Nice job. That is pretty good to me. Yeah. So let's see. All right. So good job on the first question. Everything looks fine to me. So let's move on to the second question. So in the second question, I'm going to give you an array of n integers, and there's 3 elements in it. Let's call these elements A, B, C. And you want to basically find all the elements where A and B and C, where they add up to 0. And you want to find all the unique triplets in the array, which give the sum of 0.
Did you write this down somewhere? Or
so I have this right here. Yeah. But the solution can't contain duplicates, and also if there are no triplets in the array that add up to 0, you can just return an empty array. So here's an example, and here's another example, and you might need to help comment this out. Yep. So basically, not every array given will have triplets that add up to 0, but if there are, you should return all of them that do. So yeah, let me know if you have any questions beforehand, and here's where you'll write your solution.
Okay. So So one immediate way to do this is to go through all triplets IJK indices and check if they sum to 0. And then if they do, then add it to a result and just return all of them. The runtime of that is O of n cubed because we have 3 for loops where we check all IJK pairs, triplets, and we add it to a result. We'll consider that a brute force solution. Let's see if there's a better way. So if we rearrange the equation, then you get a two-sum question.
Mm-hmm.
So if for every pair, we check if there is negative C.
Don't be afraid to also maybe sort the array. It might make your thought process more clear.
A plus B plus C 0. A plus B equals negative C. Yeah, I can't think right now. Wait, hold on.
All right, so good job on the first question. You got it all correct. So we're gonna move on to the second and last question. So in this question, I'm gonna be giving you an array of n integers, and in this array, you need to find out if there's 3 elements such that they add up to 0. And basically, I just need you to find all the unique triplets in the array which give the sum of 0. So here's the explanation. And feel free to format it in any way that you like, just to make it clearer for you. And I'll also be adding some examples here. Yeah, so if there are no unique triplets, or even if the array is not big enough, then you should just be returning an empty array. And last but not least, here is the solution. Or you should just code it.
The solution? Okay. Yes.
Here is the
okay.
You should just code it. It's just gonna be you could just throw it into a function and just go with that.
Got it. So when you say unique triplets in the array, you just mean the values of the triplets itself, right?
Correct. Yes. So unique triplets means that each triplet can have duplicate values. So it can be -1, -1, 2. There's 2 -1s here. That's fine. But if there are more -1 in the input right here, for example, you can't return. You can't return like another -1, -1, 2, and that also means you can't return a 2 -1, -1 triplet either. So each triplet must be unique in that case.
Okay. Got it. Okay. So one thing we could do immediately here, and I think I fully understand what you mean by unique triplets and what we're trying to do. And so I think a very simple way to think about this is that we can brute force this by going through every ijk pairs and summing them, summing the values of those indices and checking if it's equal to 0. And if it is, we'll throw it into our result by first checking if it's unique. And then we can do that for every ijk pair. But that complexity is O of n cubed. But it turns out we can do better by rearranging this equation. So if I go on line 83, and if I do subtract minus c on both sides, we get this equation. And so this means that if for every AB pair, we find a C that is equal to the negative of those sums, then that's a candidate for our triplet, right? So and I want to clarify, like if we have 1 and 2 as our AB, and it turns out we have a -3, then this is a candidate for our pair or unique triplet. Right. Yep. So if we do this for every AB pair and check if this negative times A plus B is in our hash map, and do a little bit of checking to make sure, take care of those edge cases where we need to make sure we have enough of those elements. Then we can just put it into a result by first checking if this is unique, and then we'll add it to a result. Okay. And so I'll implement this. We'll have some function, let's call it triplets, and it takes in some array. And first I'm going to throw it into some counter. Are you familiar with counters?
Yep, a counter should be fine. Okay. Yeah.
So for the audience watching, this is just a dictionary that basically adds all the elements and dictifies it. So this will give us a dictified version. Let's say if we have 4 of 1, then it'll give us like 1, 4. If we have 3 of 2s, then it'll say this, etc., etc. Okay, so we dictify the array, and now we can go through each element in the array. So for I in range n, for j in range I plus 1, and this ensures that we have distinct ij pairs. And then we'll sum, and we'll instantiate A as the ith, B as the j, and C must be -1 times A plus B. Now if okay, hold on. If C is not in counter, then just continue, because we don't even have a triplet with this A plus B pair. Well, if it got to line 99, we definitely have A plus B C pair triplet, but we have to do some checking. We first have to check that count. So let's say have C is the counter of C. This is how much C's we have. But A and B can be those C's. So we want to make sure we're not using A and B as our C. So we'll decrement it. If A equal to C, have C minus minus. If B equal to C, have C minus minus. Now if have C is greater than 0, we still have our C. Then we'll add it to our result. Right, and we'll add it to some hash set maybe. So we'll add it A, B, C. And we can sort these orderings. We can say A, B, C, and then we can sort it. Or we can sort it beforehand, it doesn't really matter. And we'll add this ordering. Yeah. And then we'll return result.
Okay.
All right, I think we can test it.
Try it out?
Yes, it might throw an error because I believe Python sets don't accept lists, but I'll try. Triplets, and I'll do the example you gave. Turn this.
have a print. Oh, you have a.
That's
yeah.
Okay, so it doesn't have counter. I think it's from collections. I'm actually not sure where it's from.
Yeah, it is from
Unhashable.
collections.
So we can make it a tuple.
Yeah, you could also just append instead of
Does
add.
it sort? No, I don't think it's unhashable. So I think you can't even hash a list. So yeah, I need a tuple, I think. I don't know if you can sort a tuple. Okay, so we'll do this.
You can't sort a tuple.
So we'll do this then. To add equals tuple of a to add. I think this works.
Yep, there you go.
Okay, and I think I need to print this for it to show in the command line.
Okay, nice job. Do you want to try? Do you want to try
yes.
The second one? Yeah.
Yes. All right, just return the empty set.
Perfect. Well, nice job. You just got that one correct. Yeah, that looks good to me. Yeah, it looks really good to me. Do you want to go through the time complexity and space complexity of this?
Sure. So our time complexity is bounded by these two for loops that we have. So for each n squared pairs, we do O of one work. And so the time complexity is O of n squared. And now the space complexity, do you count the returning result as our space?
No, do not include that.
Okay, so then our space complexity is bounded by the counter, which is hash map. So it's O of n space complexity.
Yep, that's correct. Well, nice job. That is a good solution, and its time complexity, space complexity looks really good. Probably the lowest time complexity you can get with this problem. Yeah. So, do you have any questions for me?